Hey guys, so today I'm going to be taking apart this Mindstormes NXT. I believe now they're on to the NXT 2.0, and this came after the RCX, I believe. And I've had this a while. You can see from many years ago I've made a few videos. But since I wasn't using it, curiosity got the better of me, and I just wanted to see what is inside. So I got pretty interested. I took apart a sensor as well. And the first thing that you see is you end up noticing that this thing is the screen here, and the button pad is plugged in via this header here, which is interesting because they bothered to make a header for that, but not for the speaker, so I don't know why bother. The interesting thing is how few connections this screen uses. I mean, this is only a 10-pin header, and yet they have a whole graphical screen running on it plus 4 buttons. So I'm not sure if for the buttons they have any multiplexing or anything, but this screen must have some sort of built onboard processor, because that's few data lines. Oops, speaker got desoldered and all my messing with it. Oh well. Anyway, if you notice here, we have here's the main processor, and this is an Atmel AT91SAM7S256. I looked that up. It's actually an ARM processor. Runs at a pretty decent specs. It's got ADCs and communications and a whole bunch of good stuff like that. So I'm not quite sure why they need an ARM, though. I mean, this is a pretty powerful chip. You know, this is not a bad chip here, and I don't know why they needed it for just something like Mindstorms that I consider not a very powerful system. I mean, this system is limited in inputs and outputs and in general power. It's a shame that Lego, at least to my knowledge, didn't offer a way to actually program this thing outside of the Mindstorm software. Or possibly put an outside header so that people like me who know electronics could interface to the chip and have a nice, when you outgrew the Mindstorms thing, at least have a decent ARM development board so you wouldn't have to buy something like the Mbed, which I have. Curiously, though, they also have an ATmega 48, and I don't know why they have this, because this chip has an onboard USB driver that can interface to this USB chip, so they couldn't be using this for USB stuff. Weird thing is they put this chip so far away from the USB port, the signal's got to go from here to here. It's just kind of strange that they're about as far away as they can get. So this chip, I don't know, they could be using it as sort of like a display driver, perhaps, so maybe, the onboard processor and the screen talks to the display driver, which talks to the main ARM chip, or maybe they're just using it as flash. I have no clue why they would need 2 processors. This ARM is definitely powerful enough to handle whatever they've got. But another thing I noticed right away that's interesting is all these electrodes, right? You'd expect on a design like this, where size is at least some of an issue, that they would, bother to put surface mount tantalums or something at least, right? It's interesting that they put electrodes, not only because they're so big, but because they're known to be failure prone, but these all look fine to me. They have ratings of 105 Celsius, 85 Celsius, so they look decently safe. It's just interesting to see such big electrodes in the design. But maybe they're probably there to filter. This is the switch mode power supply here, so maybe they determined that they needed a lot of filtering for the ARM. I'm not quite sure what speed they're running it at. The processor, this crystal here doesn't say, but maybe they needed extra filtering. I don't know, but you got your switch mode here. It's obvious because of this magnet and this transistor here. Aside from that, there's not much. Aside from you got this riser board. This thing has built-in Bluetooth functionality. This is obviously the antenna here. You can see how it sort of snakes back and forth. And then you got your 2 chips. The bigger one is a BC417. Second line is 143B0N, and the other chip is a M29W800D8. Second line is like 707E6. So it's the second line is 707E6. So I mean that's obviously the Bluetooth riser board. This is probably just a built-in module. You can see they have a little surface mount crystal right there. Yeah, it doesn't really say the frequency on it either, but interesting nonetheless. So, I'm kind of surprised at what is and isn't in here. I mean, the Electrodes were unexpected. This board is most certainly not made by Lego. No, actually it is. My bad. I thought this was just a built-in, like, Bluetooth plug-in module, but it says Lego Group on it. It may well be that they contracted out to somebody else, but that's pretty interesting. I would expect them just to use a stock riser board. It's possible they did, and they just rebranded it. The other interesting thing is this ATmega 48. Why bother? I don't know. These are most certainly like output motor drivers because they just drive those big motors with gear trains. And then over here you probably have a few multiplexers or something like that. But in any case, there really isn't a whole lot of anything on this board. I mean, this processor is pretty chunky, and this screen obviously has a at least display memory, if not a built-in processor, just because of the so few inputs on this connector. You know, like maybe they're using this for a display driver, and you know, it goes from the built-in processor, you know, from the screen memory to the built-in processor to this image processor to the main ARM. I don't know why you would bother to do that, but that's always possible. So that's interesting. And then we have this. I took apart the light sensor. You can see it just plugs in via one of these weird cables. But if you felt the desire, you could go through and replace all these with just, you know, standard telephone jacks like these. That might be just an interesting hack, just so you could use longer cables, or perhaps even build custom sensors, which would be really sweet. But then you would have to write custom code, and I don't know if Lego allows you to do that. Anyway, here you see you have the connector, and you have two lights. You have this bottom one is labeled emitter and collector. It's obviously a photodiode. And this one is labeled cathode and anode. So this top one is just a red light, actually just a red LED. And so the theory is that it bounces off and reflects back into the photodiode. And that gives you whether you're looking at something that's dark or that it's light. You know, because a white object is going to reflect a lot of light, whereas a dark object, you know, is going to absorb all the light. That's the theory, at least. It's kind of, because it works in the visible spectrum, it's kind of corrupted by room light. They should have done it at least in infrared. But then again, things are reflective and non-reflective in infrared. They're, you know, that aren't in visual light. You know, like glass is not, you know, probably this plastic window is highly absorbent in infrared, whereas it's at least semi-reflective in visual light. So, you know, that's interesting. There's not much on here. There's just a few transistors. I haven't really been able to figure out much of the pinout at all, which is kind of sad. I was hoping to be able to do something. All I figured out is that if you draw the pinout like this, so this one corresponds to this one to this one, 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 you get that these two are connected, and they're connected to ground. So they're connected to this negative spot on all of these caps here. Clearly, that's the ground pin. This pin looks like it's just not connected, right? And then this pin is connected to something, this pin is connected to something else, and this pin is connected to something else, and I can't tell. One of these must be power. My guess is it's this one, but that's totally random hunch. And then one of them's got to be an input to this ARM chip, or maybe the other chip from the photodiode. And one of them turns on and off the LED, and I believe this one actually turns on and off. So right on, off, right? Because this is this top pin here to the left is the one that's actually in charge of turning this LED on and off. So I'm not sure what you would label that as. Perhaps it's a control function, you know. That would be interesting, and that leaves just these two connections, which are both connected. So one of them's got to be power, and one of them's got to be data. If I could guess, this one's power, but again, that's a totally random hunch. this one could just as easily be power. But that probably does at least narrow down the work that you have to do. So, yeah, really enjoy your. You guys can open up. What you could do is you could open up a sensor, and you don't have to open up your Mindstorms unit. And then, based on what I know here, so ground not connected, at least for the light sensor not connected. This one controls the red LED, turns it on and off. And then this one and this one of them's power, and one of them's probably analog data coming back. So goes to the ADC. You could probably figure out a substantial amount of information, and perhaps what you could do is you could spin up your own sensor in infrared, or just put those resistive photocell things on instead, or put a blue LED or a laser, or, you know, at least just start in the process of making custom sensors. That wouldn't be all that challenging. And if you were to do that, you might as well just open this up too and replace all these with standard telephone jacks, and, you know, make your life easy. But I hope you guys enjoyed at least learning what's inside the Mindstorms and seeing what at least most of the connector looks like from the inside the sensor perspective. I haven't opened up the other sensors or motors to see what they look like, but I'd like to keep this thing still operating. But I hope you guys at least enjoyed the inside of the Lego Mindstorms. And this thing is begging for a battery hack, so 9 volt, the lifetime would be decreased by a lot. It's evident that this thing is, even though it's running on 1.8 volts, is not power efficient at all. But it's begging for you to find the power rails in here and make your own custom, or buy an off-the-shelf solution, switch mode, and run this thing off like 2 AA's. And then you could, you know, you wouldn't have to deal with the 20 battery issue thing, which really sucks. So, well, that's really it. Thanks for watching.